Welcome to our deep dive into Coulomb's law, specifically focusing on how it applies to multiple charges and reviewing key concepts. We'll explore the fundamental principles that govern electrostatic interactions and how to analyze systems with more than one charge present. This session will build upon your existing knowledge of Coulomb's law, extending it to more complex scenarios that are frequently encountered in physics and engineering. The total force on a charge is the vector sum of the forces from all other charges. This is known as the superposition principle, a cornerstone of electromagnetism. It means that each pair of charges interacts independently, and the net force on any given charge is simply the sum of all individual forces exerted on it by every other charge in the system. This principle simplifies complex multi-charge problems by allowing us to consider each interaction separately before combining them. Let's set up a problem to illustrate this principle. We have three charges positioned along the x-axis. Q1 is a positive charge of plus 2 microcoulombs located at the origin, x equals 0 meters. Q2 is also a positive charge, plus 3 microcoulombs, situated at x equals 0.10 meters. Finally, Q3 is a negative charge of minus 4 microcoulombs, placed further along the x-axis at x equals 0.20 meters. Our goal is to determine the net electrostatic force acting on Q1 due to the presence of Q2 and Q3. To find the net force on Q1, we first compute the force exerted by Q2 on Q1. Since both Q1 and Q2 are positive charges, they will repel each other. Therefore, the force from Q2 on Q1 will be directed to the left, pushing Q1 away from Q2. We would use Coulomb's law to calculate the magnitude of this repulsive force, considering the charges and the distance between them. Next, we compute the force from Q3 on Q1. In this case, Q1 is positive and Q3 is negative, meaning they will attract each other. Consequently, the force from Q3 on Q1 will be directed to the right, pulling Q1 towards Q3. Again, Coulomb's law is applied to determine the magnitude of this attractive force, taking into account the values of the charges and their separation. Finally, to determine the net force on Q1, we add these two individual forces as vectors. Since both forces are acting along the x-axis, we can simply assign positive or negative signs based on their direction and sum them algebraically. This vector addition gives us the resultant force, which represents the total electrostatic influence on Q1 from the other two charges. Understanding the superposition principle is absolutely crucial for analyzing more complex charge configurations. It allows us to break down intricate problems involving many charges into a series of simpler, manageable steps, where each step involves calculating the force between just two charges. This systematic approach is fundamental for accurately predicting the behavior of charged particles in various physical systems, from atomic structures to electrical circuits. This method ensures accuracy when dealing with multiple interacting charges, forming the very basis for advanced electromagnetism studies. Without the superposition principle, analyzing systems with more than two charges would be incredibly difficult, if not impossible. It provides a powerful tool for physicists and engineers to model and understand the forces at play in electrostatic environments, paving the way for innovations in technology and deeper scientific understanding. Let's test your knowledge with a quick quiz. Question 1. Two charges, plus 1 microcoulomb and plus 4 microcoulombs, are separated by a distance of 20 centimeters. Do they attract or repel each other? Take a moment to consider the signs of the charges. The answer is repel, because they both possess the same positive sign, and like charges always repel according to Coulomb's law. This is a fundamental concept to remember. Question 2. If you double the distance between two charges, what happens to the magnitude of the electrostatic force between them? Recall the inverse square relationship in Coulomb's law. If the distance is doubled, the force becomes 1/4 of its original value. This is because the force is inversely proportional to the square of the distance, so caret 2 equals 1/4. This inverse square relationship is a key characteristic of electrostatic forces. Question 3. Calculate the force magnitude between a charge of plus 2 microcoulombs and another charge of minus 2 microcoulombs when they are separated by a distance of 0.02 meters. You'll need to apply Coulomb's law using Coulomb's constant, the magnitudes of the charges, and the square of the distance. The answer, after performing the calculation, is approximately 89.9 newtons. This demonstrates a practical application of the formula. These quiz questions highlight the fundamental principles of Coulomb's law, particularly the inverse square relationship with distance and the crucial role of charge signs in determining attraction or repulsion. Understanding these basic concepts is paramount for anyone studying electromagnetism, as they form the bedrock for more advanced topics and problem-solving techniques. Mastering these will
significantly enhance your ability to analyze electrostatic phenomena.
Mastering these basics is essential for predicting and understanding electrostatic interactions in various physical scenarios, from the behavior of electrons in an atom to the design of electronic components. The ability to accurately calculate and interpret these forces is a critical skill for students and professionals alike, enabling a deeper comprehension of the invisible forces that shape our world and technology. To summarize, Coulomb's law provides a precise rule for the electric force between two-point charges. It states that the force is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance separating them. This mathematical relationship, coupled with the understanding of charge signs, allows us to quantify and predict electrostatic interactions with remarkable accuracy. Using this law in conjunction with the superposition principle allows us to calculate electric forces in complex systems involving multiple charges. This combined approach is not just an academic exercise. It is the fundamental foundation for understanding electric fields, electric potential, and the operation of electric circuits, which are all integral to modern technology and our understanding of the physical universe. It's a powerful toolkit for analyzing electrical phenomena. Thank you for joining us in exploring Coulomb's law and its applications, especially concerning multiple charges. We encourage you to keep practicing these principles and working through various problems to solidify your understanding. Consistent application of these concepts will build your confidence and proficiency in electromagnetism. Your dedication to learning these foundational ideas will serve you well in your academic and professional journey. We hope this session has clarified how to approach problems involving multiple charges and reinforced your knowledge of electrostatic forces. Remember, the key is to break down complex problems into simpler, manageable steps using the superposition principle. Continue to explore and question, as this curiosity is what drives scientific discovery and deeper comprehension. We look forward to seeing you in our next session.